Okay, so this is the code explanation video for the laser cat toy for MnRI Gadgets. This is actually a really simple one as far as the code goes. It's only 75 lines of code. Very easy. The first thing that I do need to explain, though, is the concept of how we think about the movement of the servos, right? So I have the circuit right over here. It's not connected to an Arduino, but I have the circuit right over here. And I'm going to try to show you this in the. I'm going to stop my share real quick. Let me show you this. So we have the circuit here, and here is the laser, right? The laser's pointing like this. We have two ways that we can control the laser. We can turn it like that, and we can make it go up and down. Now, in robotics terms, we have words for those angles of rotation. We call them yaw and pitch. So pitch is up and down, yaw is left and right. These are the same terms that we use for airplanes, for underwater robots, which I work with, and for most other robots. So whenever we see, in the code here these words yaw and pitch, that's basically just what they mean. Pitch is up and down, yaw is left and right, okay? So the code for this is actually really simple. Mostly we're just using the servo library to control those two servos. So as usual, I define the pins that I'm using up here because I like to have my pin numbers defined so that I can easily change them and so that I can easily see them if I'm rebuilding the circuit. 3 pins for this one. 1 to control the laser because I have an actual laser diode that I can turn on and off. 1 to control the yaw servo and 1 to control the pitch servo. Okay. Now we have 2 variables, yaw and pitch. These are the initial positions of our servos, and they range from 0. The servos range from 0 to 180, which is 0 degrees to 180 degrees. So they can turn in a half circle. Okay. Now, these are the initial values that worked for me with how my servos were placed and how their angles were set up, but you might have to change these to make things work for you. We have a few more variables here. I'll explain those in a second. And then the first thing that we do is we do our setup function. Now, remember in Arduino, we have a setup function that runs once and a loop function that runs over and over forever till the end of time. And this setup function does 2 really simple things. So the first thing we do is we call this attach function. Now, the attach function basically allows us to attach a servo library servo object to an actual pin. So up here we defined the yaw servo and the pitch servo, and we also defined what pins they were on. And here we're just saying, okay, the yaw servo object is on this pin, pitch servo object is on this pin. And then we write to those objects, and this is how we set it to a specific angle. We set up a servo object, we attach it to a pin, and then we write a number between 0 and 180 to it to get it to a certain angle. So we write our current yaw and pitch angles to it. Then for me, because I have a laser that is connected to the Arduino, I set the pin as an output and put it to high. Now you could, if you wanted to, turn off your laser or turn it back on again. You could do that randomly in the code here. I decided not to do it because I didn't think it was that useful. And of course, if you don't have a laser diode and you just have like a little laser toy strapped to the servos, then this won't really affect anything. And then the last thing we do is that we seed our random number generator. Now, I've talked about this in other videos, but just in case you haven't watched those, let me explain this. When we generate random numbers on a computer, what we're basically doing is we're starting with some random number. We're starting with a number, and then we do a bunch of different mathematical operations to it until we end up with a different number. And then we keep doing those mathematical operations, and they're so complex and so complicated that what we end up with seems like random numbers. But in reality, they're predetermined, right? The number that you start with sets what your first random number will be, what your second random number will be, and so on. So if you set the same first number, you're going to get the same string of random numbers every single time. And so it's important that we seed the random number generator with a different number if we want actual random numbers. So the way this is done in a lot of places in computer science is we seed a random number generator with the current time. Now, on an Arduino, the time is always 0 when we turn on the Arduino, basically. So there's not really any reason to do that. But what we can do is we can try to read from one of our analog pins, which isn't plugged into anything, and it will return this kind of just random voltage number, kind of noisy thing. We're actually kind of sampling the randomness of the universe here as our random seed. So that's why we do that. And it is important that we have random numbers because this whole laser gadget is based around randomness. The idea is it moves in random patterns, so your cats kind of just have to try and figure out where it's going to go. And we'll see that right here. So there's basically 3 parts of the randomness. The first part is we decide how much are we going to add or subtract to our yaw or our pitch angle. So how much are we going to move the laser in those angles? Are we going to add to it or subtract to it? And how long are we going to wait before doing this again? Okay? So we generate a random yaw delta. So this is going to be the difference in the angle for the yaw between 5 and 20 degrees. And for the pitch, we did 0 and 10 degrees. And then we generate this add sub yaw, add sub pitch number, which is basically a flag that tells us, do we add or subtract that delta that we just generated? So you can see here, if add sub yaw is equal to 0, we add it to the delta. And if it's not 0, or rather it's 1, we subtract it from the delta, or we subtract it from the angle. Same thing with the pitch. Then we just make sure that our angles are where we want them. Now this originally made sure that the angles stay between 0 and 170, or sorry, 0 and 180. But I realized through testing this that certain angles just really didn't work for me in my setup. For instance, if we look down here, we check to see if the pitch is greater than 100, and if we don't allow it to be greater than 100. And for me, that's because in my setup, a pitch angle greater than 100 meant that the laser was on the ceiling, and my cats did not like that because they could not catch it. So we make sure that if the pitch is greater than 100, we set it back to 100. Really, I just wanted the 100 through 50 angle for the pitch. And then for yaw, it was much larger. 170 to 30 worked for me. So if you adapt this for your setup, for your circuit, your living room, wherever you have this, make sure that you play around with what angles you're clamping to here. And it's really simple. You just change the number, these 2 numbers for the max numbers, and these 2 numbers for the minimum numbers. For yaw, and then for pitch. So that's very much how it's done. So now we've generated new values for our yaw and pitch angle. So we write them to our servos, just like we did in the setup here to write the initial angles. We write the new ones that we generated up here with our random numbers. And then we delay for some random amount of time. Now, I would recommend that you change around some of these angles, see what works for you. You can also, if you want to, try to add a random decision whether or not to turn the laser on or off. That would be pretty cool. There's a lot of things that you could add to this code, because like I said, it's a very, very simple piece of code because the actual setup with the servos and everything is a little more annoying, a little more complicated. So it's a pretty simple piece of code here. Yeah, I think the one thing I do want to say is if you do build this and you are working with it, do make sure to let your cats catch the laser. I would recommend if you are running this laser for your cats, after you turn it off, play with them with something that they can catch, like a string toy or a squishy toy, something that they can actually physically catch, because playing with a laser for long periods of time can actually kind of distress your cats. Because they can never actually catch it. So it would be a good thing to give your cats kind of the closure of catching something physical. So that's pretty much it. I don't really have anything to add. Yeah, best of luck with this. Make some modifications, find angles that work for you. And as always, stay curious, keep building things, keep taking things apart to see how they work. And I'll see you soon.